Hello, my name is Dr. Steele, and welcome to Steele Mathematics, where lessons in Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus are taught. And today, we're going to talk about arcs and angles. What is an arc? Imagine that you have a hula hoop, and you want to cut a piece out of it. So there's the piece that is cut out, and that piece is called an arc. It is a piece of a circle. Now, arcs are named for their endpoints. Therefore, the name of the arc is arc AB or arc BA. And as you can see on the bottom, there's a symbol for the arc. It's the name of the 2 points with an arch over it. Okay? That means it's an arc. But now let's look at this. We have arc AB. And you're probably wondering, well, which is arc AB? The small one or the big one? So to lessen the confusion, arc AB is called a minor arc. And of course, minor arcs are named with 2 letters. The big one, the green one, arc ACB, is called a major arc. And major arcs are named with 3 letters. So now you can distinguish one arc from the other. Then we have what we call semicircles or half circles. So arc ACB and arc ADB are semicircles. And just like with the major arc, semicircles are also named with 3 letters. An angle intercepts an arc if both sides intersect a circle. So you can say that angle APB intercepts arc AB. Another way to look at this is it seems like the angle is sort of biting the arc, and the arc is inside its teeth. Well, arc AB is inside the teeth of angle APB. So you can say that angle APB intercepts arc AB. What I want to do now is I want to tell you about the types of angles and how it relates to the arc it intercepts. First, we have what is called a central angle. Its vertex happens to be the center of the circle. So angle APB is a central angle because P is the vertex of angle APB and P is the center of the circle. The measure of a central angle equals the measure of the arc it intercepts. So the measure of angle APB equals the measure of arc AB. Of course, the M in front means the measure of. So now here's a different type of angle, and that would be called the inscribed angle if its vertex is on a circle and it's inside the circle. So as you can see, angle ACB is inside the circle and C is on the circle. So angle ACB is an inscribed angle. Now, how is an inscribed angle related to the arc it intercepts? the measure of an inscribed angle equals 1/2 the measure. So therefore, the measure of angle ACB is 1/2 the measure of arc AB. So far in this lesson, we have the central angle, and the measure of a central angle is equal to the measure of the arc it intercepts. Then we have the inscribed angle, where the measure of the inscribed angle equals 1/2 the arc it intercepts. So now we have another angle, one that is formed by a tangent and a chord. The measure of an angle formed by a chord and a tangent equals 1/2 the angle it intercepts. Therefore, the measure of angle ANM equals 1/2 the measure of arc MN, and the measure of angle BNM equals 1/2 the measure of the arc MHN. Remember, MHN is a major arc and it's named with 3 letters. An arc corresponds with a chord if the arc and the chord have the same endpoints. So arc AB corresponds with segment AB. They both have the same endpoints. Arc CD corresponds with segment CD. They have the same endpoints. Two arcs are congruent if and only if their corresponding chords are congruent. So what it's saying is arc AB is congruent to arc CD if and only if segment AB is congruent to segment CD. Looks like it makes sense, doesn't it? The measure of an angle formed by 2 intersecting chords equals 1/2 the sum of the measures of the arc intercepted by the angle and its vertical angle. So what this theorem is saying is the measure of angle AOC equals 1/2 the sum of the measures of arc AC and BD. The measure of angle AOD equals 1/2 the measures of arc AD and arc BC. Finally, we have the measure of an angle formed by 2 lines intersecting outside of a circle is 1/2 the difference of the measures of the arc it intercepts. So when we talk about 2 chords intersecting inside of the circle, the measure of the angle equals 1/2 the sum of the 2 arcs. Now we have an angle formed outside the circle, and that's 1/2 the difference of the 2 arcs it intercepts. So in other words, the angle can be made by 2 secants, 2 tangents, or a secant and a tangent. Therefore, the measure of angle C is 1/2 the measure of arc AB minus the measure of arc BD. The measure of angle H equals 1/2 the measure of arc FI minus the measure of arc GI. And the measure of angle J equals 1/2 the measure of arc MLK minus the measure of arc MK. One last thing I want you to know before I give you this example. Or should I say these examples? The total degree measure of a circle is, drum roll please, 360 degrees. So now let's look at some examples. Let's say you ask to find the missing measures. The measure of an angle is 87 and it wants you to find the measure of the arc. Well, that angle is a central angle. And if you remember, the measure of a central angle equals the arc it intercepts. Therefore, the measure of the angle is 87. The measure of the arc is 87. 87 degrees. All right, number 2, we have an angle that intercepts an 87 degree angle and its vertical angle intercepting the 61 degree angle. Well, notice that the angle is made by 2 intersecting chords inside the circle. Therefore, it will be 1/2 the sum of the angles. So 61 plus 87 equals 148. And therefore, 1/2 of 148 is 74 degrees. So the solution is 74. Number 3, we have an inscribed angle. And an arc intercept is 96. Well, the measure of an inscribed angle is 1/2 of 96. Therefore, 1/2 of 96 is 48 degrees. All right, next on number 4, we got an angle formed by a chord and a tangent, and the arc intercepts is 100. The measure of the angle is 1/2 that arc. Therefore, the measure of that angle is 1/2 of 100, which is 50 degrees. Number 5, you have the measure of one arc, you ought to find the other. Well, as you can see, their corresponding chords are congruent. Therefore, the 2 arcs are congruent. So if one arc is 105 degrees, the other one has to be 105 degrees. All right, next, we have an angle that is formed by 2 secants intersecting outside of the circle. And the 2 arcs they intercept are 153 degrees and 59 degrees. Therefore, that angle will be 1/2 the difference of those 2 arcs. So this will be 1/2 of 150 degrees minus 59 degrees. So now we do 153 minus 59. That'll give you 94. And 1/2 of 94 is 47 degrees. All right, now let's look at these examples. Let's say you ask to find the value of x. Well, we have a central angle, which is 9x plus 2, and the arc intercept is 11x minus 8. Well, we know that the measure of the angle equals the arc it intercepts. Therefore, we have 9x plus 2 equal 11x minus 8. We subtract 9x from both sides, and we have 2 equal 2x minus 8. Add 8 to both sides, and you'll get 10 equal 2x. Divide both sides by 2, you'll get 5 equals x. Therefore, the solution is 5. On number 8, we have two arcs, 3x plus 49 and 5x plus 7. The chords, as you can see, are congruent. Therefore, the arcs got to be congruent. Therefore, 3x plus 49 equals 5x plus 7. We subtract 3x for both sides. So we have 49 equals 2x plus 7. We subtract 7 from both sides, and you'll have 42 equal 2x. Divide both sides by 2, and you'll have 21 equal x. Therefore, the solution is 21. On number 9, we have an angle that are formed by two chords intersecting each other inside the circle. The measure of the angle is 1/2 the sum of the two arcs. Therefore, 65 equal 1/2 of 7x plus 5 plus 10x minus 11. We'll go ahead and combine the like terms. 7x plus 10x is 17x. And 5 plus negative 11 is negative 6. So now what we're going to do is we're going to get rid of the 1/2, and we multiply both sides by 2, which is the reciprocal of 1/2. So now we have 7x minus 6 on this side, and 2 times 65 is 130. Add 6 to both sides, and we have 136 equals 17x. We divide both sides by 17, and you get 8 equal x. Therefore, 8 is a solution. Finally, we have an angle that is 70 degrees made by a tangent and a secant. They intersect outside the circle. And the two arcs they intercept are 6x minus 7 and 2x plus 3. The measure of that angle is 1/2 the difference of the two arcs. Therefore, 70 equal 1/2 of 6x plus 7 minus 2x plus 3. We're going to go ahead and combine the like terms. 6x minus 2x is 4x, and 7 minus 3 is 4. Now, to get rid of 1/2, we multiply both sides by 2. 1/2 and 2 will cancel out, so we have 4x minus 4. 2 times 70 is 140. Add 4 to both sides, and you have 144 equal 4x. Divide both sides by 4. And you would get 36 equal x. Therefore, the solution is 36. That seems to be a lot to take in, but it basically comes down to not so many points. The first point is the measure of a central angle equals the arc, and the measure of an inclined angle equals 1/2 the arc. The arc corresponds with a chord if they share the same endpoints. And those arcs are congruent if those two chords are congruent. When an angle is formed inside a circle, the measure of the angle is 1/2 the sum of the two arcs. And if the angle is formed by two intersecting lines outside the circle, the angle will be 1/2 the difference of the two arcs. I hope that you have a wonderful and blessed day.